Welcome to our latest project brought to you by MevaHub.com, where we explore the exciting world of bidirectional CAN communication between Arduino and TMS320F28379D microcontroller. If you're passionate about electronics, microcontrollers, and cutting-edge technology, you're in the right place. Before we begin, don't forget to subscribe to our channel and visit MevaHub.com for more tutorials, projects, and resources to fuel your creative endeavors. Why bidirectional CAN communication matters. Imagine you're working on an automotive or industrial project where real-time data exchange is crucial. Bidirectional CAN communication allows devices to both send and receive data, enabling a seamless flow of information between different components of a system. This is invaluable in scenarios where timely and accurate data transmission is paramount for safety, efficiency, and functionality. Example scenario. Let's consider a scenario where an autonomous vehicle needs to communicate with various sensors and actuators. The vehicle's Arduino-based control unit must send commands to the TMS320F28379D microcontroller, which in turn processes the data and responds accordingly. Meanwhile, the TMS320F28379D might also need to transmit diagnostic information or sensor readings back to the Arduino for monitoring or logging purposes. Cost comparison. Traditionally, analyzing CAN communication required expensive hardware such as CAN analyzers, which come with a hefty price tag. However, the MCP2515 CAN bus module offers a cost-effective alternative without compromising functionality. Priced significantly lower than dedicated CAN analyzers, these modules provide a budget-friendly solution for hobbyists, students, and professionals alike, all available at MevaHub.com. Components required. Present a list of components needed for the project, including Arduino UNO, TMS320F28379D, MCP2515 CAN bus module, etc. Provided links to purchase these components. Setup and wiring. Let's delve into the detailed setup and wiring process to establish bidirectional CAN communication between an Arduino and a TMS320F28379D microcontroller using MCP2515 CAN bus modules. Follow these steps carefully to ensure seamless integration of the components. Gather your components. Before you begin, ensure you have all the necessary components ready. Arduino board, such as Arduino Uno or Arduino Mega. TMS320F28379D microcontroller development board. 2 MCP2515 CAN bus modules. Jumper wires. Breadboard, optional, for prototyping. Connect the MCP2515 modules to Arduino. Wire the MCP2515 modules to your Arduino board. VCC and GND. Connect the VCC pin of each MCP2515 module to the 5V pin on your Arduino. Similarly, connect the GND pin of each module to any GND pin on the Arduino. SPI pins. Connect the SPI pins of each MCP2515 module to the corresponding SPI pins on the Arduino, MISO, MOSI, SCK, and CS. INT pin. If your MCP2515 modules have an INT pin, connected to any digital pin on the Arduino that supports interrupts, e.g., digital pin 2 or 3. Connect the MCP2515 modules to TMS320F28379D. Wire the MCP2515 modules to your TMS320F28379D board. Power up your system. Power up both your Arduino and TMS320F28379D boards. Verify that both devices are receiving power and functioning correctly. Configure your software. To establish communication between the Arduino and TMS320F28379D, configure the MCP2515 modules and write appropriate software code for both platforms. This includes setting board rates, initializing CAN controllers, and implementing message transmission and reception protocols. Test your setup. After completing the setup and configuration, it's time to test your bidirectional CAN communication. Send test messages between the Arduino and TMS320F28379D to verify that data transmission and reception are working as expected. Discover the Arduino code for CAN transceiver available at mevihub.com and explore the TMS320F28379D code for CAN transceiver also accessible at mevihub.com. Explanation about transmitting CAN messages via serial communication. In this scenario, the Arduino is configured to transmit CAN messages via serial communication to the TMS320F28379D microcontroller. Serial communication initialization. Serial communication is initialized with a baud rate of 9600. This ensures that both the Arduino and the receiving device, TMS320F28379D, are synchronized in terms of data transmission speed. MCP2515 library and SPI setup. The code sets up the MCP2515 library and SPI communication. This allows the Arduino to communicate with the MCP2515 CAN controller module using the Serial Peripheral Interface (SPI) protocol. MCP2515 module configuration. The MCP2515 module is reset, and the CAN bus bit rate is configured to 500 kbps using an 8 MHz crystal oscillator. This ensures that both the transmitting and receiving devices are operating at the same baud rate, enabling successful data transmission. Serial data reception. The code continuously checks for incoming serial data using the serial.available function. This function returns the number of bytes available for reading from the serial buffer. Extracting CAN ID and data bytes. The received data, assumed to be in the format CAN_ID data_BYTE_1 data_BYTE_2 data_BYTE_8 inch, is passed to extract the CAN ID and data bytes. The CAN ID represents the identifier of the CAN message, while the data bytes contain the actual payload of the message. Constructing and transmitting CAN message. Once the CAN ID and data bytes are extracted, a CAN message is constructed using this information. The message is then sent using the MCP2515.sendMessage function, which interfaces with the MCP2515 module to transmit the message onto the CAN bus. confirmation message. After sending the CAN message, a confirmation message is printed via serial communication. This serves as feedback to the user, indicating that the CAN message has been successfully transmitted. Example packet for serial transmission. Here's an example of dummy data that can be transmitted through serial communication from the Arduino to the TMS320F28379D. Copy code 2421 32 23 14 45 26 27. In this example, 24 represents the CAN ID. 21, 32, 23, 14, 45, 26, 27, and 18 represent the 8 data bytes associated with that CAN ID. Each value is in decimal format. Adjust the CAN ID and data bytes as needed for your specific application, ensuring that each value is separated by a space when transmitting the data through serial communication.